Okay, we're on lesson 11, part 2. Question number 4. It says, Sally and her friends decided to start a business selling school sweatshirts and school jackets. They will make a profit of $4.10 per jacket and $2.80 per sweatsuit. That's profit. How many of each can they sell to produce the major points of profit and stay within the following conditions? A says they know that they will sell at least 35 jackets. B, the most sweatshirts that they could sell is 56. C, they expect to sell at least 3 times as many jackets as sweatsuits. And D, they will sell no more than 100 total items. So we're going to take all of those constraints on this business, and we're going to write an inequality. We're going to graph and shade 4 inequalities, and we're going to get a geometrical region that's shaded in, and we're going to study the corners of those geometrical regions. And we're going to get 4 ordered pairs as we look at the intersection of the lines that hit those corners, okay? Now, it says step 1, write an equation for total profit, letting Y be jackets and X be sweatsuits. On this page, we're going to write this and then transfer it. So jackets, it called Y. Is that correct? Jackets, Y. So everywhere there's jackets, I'm going to put a Y. And sweatsuits, S, just so I don't make any mistakes. Sweatsuits, S. Jackets, Y. Now, somebody give me a profit equation. They make $4.10 per jacket, Y, $2.80 per sweatsuit, S. That's the profit. So what's my profit going to be? Profit is equal to, what's my profit equal to? Y'all help me out here. It's $4.10 per jacket Y. So profit equal $4.10Y plus $2.80S. $2.80 per sweatsuit S. Okay? And so we have a profit formula. We're going to plug the corners of our geometrical region into that profit formula later to take a look at the possible profit that could be made given these constraints on this business. The other thing it asks us to do, number 2, as you can still see on the screen, is write an equation or an inequality for A, B, C, and D. And then we're going to graph those. So we're going to write this here since we can see the work, and then we'll move them to the next page. They will sell at least 35 jackets. Now, how are you going to write an inequality for that? The number of jackets, Y, you understanding that? Will need to be at least. How do you write at least? That much are more. At least means that much or more, which would be greater than or equal to. The equal to is the that much, right? That much or more. See how that works? That much or more. Then 35. At least 35 means 35 or more. Equal to 35 or more than 35. Greater than or equal to. They say we got the inequality for A. B says the most sweatsuits that they could sell is 56. If the most is 56, that means it is 56 or less. The number of sweatsuits is 56 or less. If the most is 56, then it's 56 or less. They see that? Kind of got to these. They expect to sell 3 times as many jackets as sweatsuits. Now, this is actually on page 38 of my Algebra 1 book in chapter 2. And a lot of people have trouble writing an inequality for C. And I'm just going to see what people say. What do you think the equation or inequality is going to be? Now, first of all, am I going to have a y and then a 2x, or am I going to have an x and then a 2y? I mean 3, excuse me. Is the 3 going to be on the y or the x? That's my question. How many say it's going to be on the x? 1. How many say it's going to be on the y? 1. How many don't know for sure? A whole bunch. And this is what happened in Algebra 1. And if you remember in Algebra 1, we created what we called the big little trick for this kind of problem because people have trouble with this. Now, you realize if one is 3 times the other, there's a big one and a little one? So what I'm going to write on my paper here is I'm going to write big equal 3 littles. Now, does everybody agree with that? It takes 3 littles to make a big. 3 littles equal a big. Now, which one's the big one? There's at least 3 times as many. See that y is the big one? There's at least 3 times as many of it. So y is the big one, so the 3 goes on the x. So we use the big little trick to figure out that the 3 went on the x, not the y. Remember that from way back yonder? All right, everybody good with that? Big little trick. It'll help you out on that. And now, it said at least. At least means what? That much or more. See that? These are hard. Doesn't matter if you're in Algebra 1 or pre-calculus. It's still hard. Everybody see what we've done, though? You might want to watch that video again and again and again to see how we did that. Okay? D, they will sell no more than 100 total. Okay, 100 total. How are we going to write that? Y plus S, there's your total. And there's your 100. If it said the total is 100, we'd put y plus s equal 100, right? But it says no more than 100. Now, what does that mean? It means less than or equal to 100. No more than 100 means 100 or less. But the total is the sum of the items, you see. This is some pretty powerful problem right here. There's a lot of stuff buried in this one. I don't know who made that thing up. It was fun to make that up. I just put everything I could in it just so we could get a good review. Everybody said we got those 4 inequalities. Everybody okay with that? I need to redo any of them? Okay. All right. So, y'all got those written down. We're going to move to the next page, and it's reserved for some work here. We'll go back to that. But we need the graph, right? Okay. Now, my inequalities, what was my first? What was A? Let's get this work back. A was what? Y is greater than 35. B was S is less than or equal to 56. And then C was greater than or equal to 3x. And D was y plus x is less than or equal to 100. Now we've got to graph those 4 things on a coordinate plane. I put S instead of X, excuse me. We should call that X. Oh, we called it S, didn't we? But I meant I was supposed to call it X. Y'all knew I was supposed to call it X. Yes, because it said let sweatsuits be X. I shorted out there because we're going to put it on the coordinate plane. Wherever we put an S, put an X. Sorry. Yeah. Oops. Now, we need to figure out where our origin's going to be. Bear with me. I'll try to make this straight. Now, X is sweatsuits and Y is jackets. Is that correct? What is the maximum number of sweatsuits? 56. So we can grid this out however we want. Maybe we would do 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. We've got to get X is 56 or less, so we just wanted to make sure we got bigger than 56. See. What about Y? It's 35 or more, but what's the most Y could be? Well, the total's 100, so the most you're going to have of either one's 100. Of course, the most you're going to have of sweatsuits is 56. But you could have 0 sweatsuits and 100 jackets, right, if we think through it. So we're just going to go 5 here, 5, 10, 15, 20. I got to get bigger. I got to get to 100, right? As we better do 10 because we need to make it to 100. Sorry about that. I should have done it to start with. 10, 20, 30, 40. All right. That way we envelop all the possibilities in our graph. And now we're going to graph those 4 inequalities and find the overlapping shaded region, which is going to create a geometrical shape. So we'll just start with the one in blue. Y is greater than or equal to 35. How do you graph that? Y only is a what kind of a line? Y only the other one. Horizontal. Y only is horizontal. Solid or dotted. It has the equal mark, so it's solid. So it's a solid horizontal line through Y is 35. That's an inequality, so there's shading. It says Y is greater or bigger. Which direction does Y get bigger? Up, so we shade up. You might want to not want to go too awful dark because it might be a little bit hard to find our little geometrical shape if it's all blacked out. All right, and the second one is an X only. An X only is a what kind of a line? Vertical. Solid or dotted. Has the equal mark, so it's solid. So it's a solid vertical line through X is 56, which is going to be right in here somewhere. I'm going to label these. The line itself is X equal 56. Everybody agree with that? The line itself here is Y equal 35. We're going to need that because later on we're going to use those intersections of those lines. So we need to know what the line was. Okay? And then the black again, it says X is what? Less than. Which direction on the graph does X get smaller? To the left. X gets smaller to the left. So we shade to the left. Good sound effects. All right. I really don't have to graph past the axes, right, because you can't have negative of them. Okay, so you realize your XY axis is also a boundary because you can't have negative jackets and you can't have negative sweatsuits. So there's 2 other possible boundaries that could jump in. Okay, y is less than, greater than or equal to 3x. What's the y-intercept there? 0. And the slope is 3 over 1, which means to go up 3 right 1. So this graph will begin at the origin 0, 0. We want to go up 3 right 1, but look at our grid. That's not very pretty, is it? So we would rather not do that. What's a pretty number on your X grid? 10 or 20? So I'm going to take that 3 over 1, and I'm going to multiply it by 20, and it's going to say up 60 right 20. See how I enlarged my slope so I can deal with it better? I don't want to try to go up 3 right 1 when my grid is by 10s and 5s. So I'm going to go up 60 into the right 20. Up 60 right 20 would be here. See that? I'm missing. And then I could go up 60 again, which would put me at 120. Enter that 20 again, which would put me at 40. Which put me about right there. So I enlarged my slope. Solid or dotted? It's got the equal mark, so it's solid. That one goes into infinity. But it's going to be topped off by the last one. It says y is bigger. Which direction does y get bigger? So how do you figure out where up is? You start on the line itself and go up. You start on the line itself and go up. Start on the line itself and go up. Looks like you're shading left, but you're not. You're shading up. Now I'm going to label that. That was y equal 3x as far as the equation is concerned. Because we're going to use those equations to find the corners. Okay? Now, the other thing we have is, and I can't erase it out, is this right here. And I'm going to move it over here. It looks like y plus x is less than or equal to 100. We can't graph that because it's in standard form. If we're going to have to graph it, we're going to move it into slope-intercept. And to do that, we're going to move the x to the other side, remembering to change the sign when you cross over, so you get y is less than or equal to negative x plus 100. So we changed that one from standard form into slope-intercept form so that we can identify its slope and its y-intercept and graph. There's a whole lot of math in this little problem. The y-intercept of that one was 100. So it begins at 100. That's here. And then the slope is negative 1 over 1, right? Which I'm going to do 20. Multiply by 20. Multiply by 20. It's going to give me negative 20 over 20. Understand that? I enlarged my slope of negative 1 over 1 to negative 20 over 20. So from the 100, I'm going to go down 20, right 20. So that put me at 20 and 80. Down another 20, right 20 would be at 40 and 60. Right another 20, down 20 would be at 60, 40. Solid or dotted? I missed on that one. That point got off. Okay. This one is dotted, right? Was it, did it, no, see, it's solid because it had an equal mark. So it's a solid line. It says y is smaller, so you shade down. And in y equal form, this was y equal negative x plus 100. I'm going to try to highlight the names of the equations because it got a little crazy. So the green one is y equal 3x. The black one is x equal 56. The red one is y equal x negative x plus 100. And the blue one is y equal 35. Okay? Now, where did they hit? Well, if you look, we've got the red, blue, black, and green meet here. And the green line is coming through here, right? So that green line boundaries to there. It cuts through here and hits the blue right there. Can you see that? Did I miss? The red is going down. The black is going right. The black is going up, but it's in that region. I'm going to come down here to this corner. The blue goes above that, and then I've got this boundary. So there's my geometrical shape right there. The black vertical line, but the black is going this way, so it's in that box. But see, the green cut us off before we made it to the black boundary. See? And the blue cut us off in this boundary, right? The red cut us off up here. So the blue, green, and red trapped us from going further to the right, up, and down. And then my axis cut me off right here. It's kind of hard to tell that. It's so much stuff. All right, yeah. All right, so we've got 4 corners. All right, what I'm going to do is, what we need to do now is we need to find those corners, right? And I think the best thing for me to do is just white stuff out and clean up and leave the picture there, okay? So let me try this. Oh, that's not good. Come back. Okay, I missed. I think I'll just white out my smart. It's not going to hide it. I'll minimize it. Ooh, come back. Come back. Come back. Ooh, come back. Oh, no. Oh, no. And it's recording that I'm saying, oh, no. I just lost it all. Wow. That was not nice of it at all. I don't think it'll let it come back. Click here. Come back. No, it's gone. Wow. Oh. No, I better not do that. Let me. Okay, we had a little. We lost all our stuff, so we recreated it. It's probably prettier anyway. We have a geometrical shape, and I drew each of the lines in a color, and I wrote the equation of that line that created that shade in that appropriate color. Now what we want to do is find the 4 corners. So I'm just going to name those 4 corners. I'm going to say top left. Top left. Okay? I did that totally weird, but anyway, top left. So we're going to find the top left corner. That's this one. It comes from the equation x equals 0 and the equation y equals negative x plus 100. That's the 2 things that hit the top left corner. So we're going to solve that system. To do that, we can put 0 in place of x right here. And we will have y equals 0 plus 100. And so we would get y is equal to 100. And so this corner is 0, 100. That means that you would sell 0 sweatsuits and 100 jackets. That's possibility 1. Did I mess that up? The question was this, that blue line, they're like, where did that come from? If you remember, our figure came out from like this right here. Maybe my x-y axis is here. And this was that horizontal line, y equal 35. But that left side is actually the x-axis, and x is equal to 0 right here because it's the origin 0, 0. So the equation is x equals 0 because it's a vertical line. So the equation of the y-axis is the vertical line, x equals 0. Okay, everybody good there now? Okay, so we've got that corner. Now we're going to do the top right corner, which is this one. It's the intersection of the equation y equal 3x and the equation y equal negative x plus 100. Now, we need to solve by substitution. I'm just going to put the 3x in place of y, and it would give me 3x is equal to negative x plus 100. Now I have an x only. I'm going to move this to the other side, remembering to change the sign when you cross over. I get 4x is equal to 100. Divide by 4, and I would get x is equal to 25. I'm going to take that 25, plug it back in, and I'll get y equal 3 times 25, and so I'm going to get y equals 75. So the coordinates of this corner right here are 25, 75. That says that you might sell 25 sweatsuits and 75 jackets. We're getting the possible maximum sales. See, the greatest total sales is 100. It's going to come out to be 100 every time. But we're kind of getting this maximum idea of profit that might come up. Okay, everybody see what we've done? All right, so we got to keep finding corners. We got 2 more corners to find. The next corner, we'll just do the bottom left. Bottom left. The bottom left corner comes from the equation x equals 0 and y equal 35. So that's pretty easy, huh? 0, 35. That one was easy to find. And now we're going to find the bottom right corner. And it comes from the equation y equal negative x plus 100 and the equation y equal 35. So we're going to put the 35 in place of the y and get 35 is equal to negative x plus 100, and then isolate the x. So we're going to subtract 100. Mess up. It is. Thank you. Yes, I grabbed the wrong equation. This was the y equal 3x. Thank you very much. I grabbed the wrong equation. So that bottom right, excuse me, thank you very much, is from the y equal 3x and the y equal 35. Much better. Y equal 3x, the green one, and y equal 35, the red one. Very good. So we're going to take the 35 and plug it in. So we get 35 is equal to 3x. Divide by 3, and we would get x is equal to 11 2/3, which is impossible. So we just as well make it 11 because you can't sell 2/3 of a sweatsuit. Okay? So this corner is 11 and 35. I'm sorry. Wow. This corner is 11 and 35. Did I forget? Oh, okay. Notice that the top two corners maximize sales of 100 items, but the bottom two did not maximize sales. Okay? Now, what it wanted us to do is find maximum profit. What are the possible profits that you could make? Now, we realized when we start a business, we don't need to just look at maximum profit. We need to look at minimum. Is there the idea that you could lose money? Or if I'm going to start a business, am I going to be happy with working all month for this amount of money? So what's the possible amount of money I could make? And we're going to find those four, the money, and all that stuff in the middle is going to be somewhere between those four things, you see. It's going to be somewhere in between there, so it gives us an idea of what's happening. So we're going to plug our corners into our profit formula. So I'm going to do the top left first. If we plug in the top left corner, we get that P is equal to 410 per Y, which is 100, plus 280 per X, which is 0. And we would get $410 for profit, right? If we plug in the top right, we're going to have $4.10 per Y, which is 75, plus 280 per X, which is 25. Somebody punch that out in the calculator and give me the answer, if you will, please. I'm going to keep going. If we do the bottom left, we would have $4.10 times 35 items plus $2.80 times 0 items. And if we do the bottom right, we're going to have 410 times 35 items plus 280 times 11 items. So what's the top right answer? 377.5, so $50. $377.50. What is the bottom left answer? 143.5, $143.50, and the bottom right, 174.30. So given all that information, we can reach the conclusion here that the worst they could do is make $143.50, and the best that they could do is make $410. And then what they'd need to do is look at time invested and say, okay, is this worth it for us? Is it worth it for us to try to do this? So that's a pretty neat problem. It gives us a lot of math in there, but it's amazing how we can actually find the profit arena, 143.50, 174.30, 377.50, 410. Everything else has to be in the middle of all that somewhere, you see. Any questions on linear programming? Yeah. Does anybody have that? Okay, it asks us, I'll have to go back to the question. It asks us to plug those corners back in. It asks us to find the corners and then plug them back into the profit formula to find the possible profits. Okay? Right? But, yes. The question was, can we just skip this? And the answer is no. But what goes with that is I'll have a lot of retests run off because you're probably going to do this more than once. It's not